Arithmetic. Arithmetic is the foundation of all math. It's about working with numbers, adding, subtracting, multiplying, and dividing them. Imagine you're planting a garden. Arithmetic helps you calculate how many seeds you need for a row, or how much soil to buy for each bed. It's also used to track expenses, measure time, and adjust recipes in the kitchen. From budgeting a project to programming a robot, arithmetic gives us the tools to work with numbers everywhere. Algebra. Algebra goes beyond numbers and explores how symbols and equations represent relationships. It's like solving puzzles where letters stand for unknown values. For example, let's say you buy 3 apples and 4 bananas, and the total cost is $10. If you know each apple costs $2, how much does a banana cost? Algebra turns this into an equation. 3 times 2 plus 4 times x equals 10, where x is the cost of 1 banana. Engineers use algebra to calculate how much weight a bridge can hold safely. Architects rely on it to design buildings that stand strong against wind and weather. Even animators use algebra to create smooth character movements in movies and games. Geometry. Geometry is the math of shapes, sizes, and spaces. It helps us measure and understand the world around us, from the lines and angles in a building to the curves of a soccer ball. For example, if you're designing a playground, geometry helps calculate the area needed for swings or slides. Architects use it to create earthquake-resistant buildings, while scientists rely on it to map planetary surfaces and design spacecraft trajectories. Whether calculating the safest bridge design or plotting the path of a rover on Mars, geometry transforms ideas into tangible achievements. Trigonometry. Trigonometry studies angles, triangles, and how their sides relate to each other. It helps measure distances, calculate directions, and solve real-world problems. Surveyors use trigonometry to measure the height of mountains by analyzing angles. GPS systems depend on it to pinpoint your location, using signals from satellites. A ship at sea relies on trigonometry to navigate safely, calculating its position and route based on the stars. Astronomers use it to measure the distance to faraway stars, turning angles into numbers that reveal the scale of the universe. Statistics. Statistics is the math of data. It helps us uncover patterns, test ideas, and make informed decisions. Doctors rely on statistics to compare the outcomes of new vaccines, analyzing results from thousands of patients to ensure safety and effectiveness. Weather forecasters use it to predict storms by studying patterns in temperature and wind. Sports analysts evaluate player performance to design winning strategies. Businesses analyze customer data to understand spending habits and improve services. Even farmers use statistics to predict crop yields, ensuring enough food is grown to meet demand. Calculus. Calculus is the math of change. It helps us understand how things grow, shrink, or move, revealing the hidden patterns of motion and transformation. Engineers use calculus to design roller coasters, calculating the forces needed to keep them safe and thrilling. Scientists apply it to track how medicine flows through the bloodstream, ensuring accurate dosing. Ecologists use calculus to study population changes in ecosystems, predicting how species adapt over time. Even space exploration depends on calculus to calculate rocket trajectories and planetary orbits. Only 1% can solve this math problem and hit like in 5 seconds. Ready? Go! Tell us in the comments whether you nailed it or not. Differential equations. Calculus studies change, how fast something moves or grows. Differential equations use those tools to model systems where changes depend on each other. For example, they describe how a pendulum swings, connecting its speed and position at every moment. Engineers use them to keep airplanes stable during flight, adjusting for forces like wind and turbulence. Differential equations also help simulate how water flows through pipes, ensuring steady pressure in cities. Unlike calculus, which focuses on individual changes, differential equations map entire systems in motion. Linear algebra. Linear algebra is the math of vectors, matrices, and systems of equations. It organizes data and solves problems in spaces with many dimensions. In artificial intelligence, linear algebra is essential. Neural networks, which power voice assistants and image recognition, use matrix operations to process and learn from data. Streaming platforms like Netflix rely on it to suggest movies by comparing your viewing history to others with similar tastes. Even self-driving cars use linear algebra to interpret sensor data, calculating the safest route in real time. Number theory. Number theory studies whole numbers and their unique properties. It's about finding patterns and understanding the rules behind them. Prime numbers, for instance, can only be divided by 1 in themselves. Cryptographers use these numbers to create secure systems, like protecting online bank accounts or private messages. These same principles are the foundation of cryptocurrencies like Bitcoin, where prime numbers help keep transactions safe from hackers. Number theory also helps engineers fix errors in data transmission, making satellite signals clear and reliable. Set theory. Set theory studies collections of objects, called sets, and how they interact. It's about grouping things and finding relationships between them. For example, your playlist of favorite songs is a set, and your friend's playlist is another. Set theory explains how to find songs you both love, called intersection, or all songs from both playlists combined, called union. It's also used in databases to sort and organize information, like finding shared customers across 2 companies or matching job seekers with openings. Graph theory. Graph theory studies how things are connected. It uses points, known as nodes, and lines, called edges, to model relationships and networks. For example, a map of roads connecting cities is a graph, where cities are nodes and roads are edges. Social networks like Facebook use graph theory to show how people are linked as friends. Search engines rely on it to rank websites, analyzing connections between pages to deliver the best results. Logic. Logic is the study of reasoning. It helps us decide what's true or false by following clear rules. Computers rely on logic to perform calculations, from simple math to running programs. Circuit boards in your devices use logic gates, tiny switches that combine signals to process information. Programmers write algorithms with logical conditions like if this, then that, to create games, apps, and websites. Logic also powers database queries, enabling systems to sort and filter massive amounts of information accurately. Theory of computation. The theory of computation explores what problems computers can solve and how efficiently they can do it. It studies the limits of algorithms and the power of different types of machines. For example, programmers use this theory to create algorithms that search millions of websites in seconds. It's also used to design efficient scheduling systems, like assigning flights to pilots or optimizing delivery routes. Researchers even use it to simulate traffic flow in cities, reducing congestion and improving transportation networks. Game theory. Game theory studies how people and organizations make decisions when their choices depend on others. It helps predict outcomes in situations where everyone wants the best for themselves. Economists use game theory to study competition between businesses, like how companies set prices. Governments apply it to negotiate treaties or manage shared resources like water or fishing zones. Biologists study animal behavior through game theory, uncovering how cooperation and competition shape ecosystems. Information theory. Information theory studies how data is transmitted, stored, and processed efficiently. It's the math behind everything from streaming videos to sending texts. For example, compression algorithms like those used in MP3 files or video streams rely on information theory to shrink data without losing quality. It's also used in image processing, where algorithms sharpen photos or reduce file sizes for sharing online. In noisy environments like decoding signals from space probes or reducing static in phone calls, information theory ensures clear communication. Mathematical physics. Mathematical physics uses math to describe and predict how the universe works. It connects equations to natural forces like gravity and electromagnetism. Scientists use mathematical physics to simulate the behavior of stars and galaxies, revealing how the cosmos evolves. Engineers apply it to create magnetic resonance imaging, which capture detailed images of the human body. It's also used to design fusion reactors, aiming to produce limitless clean energy by replicating the processes inside the sun. Topology. Topology studies the properties of shapes that stay the same even when they're stretched or bent. It's often called the rubber sheet geometry. For example, a coffee cup and a donut are the same in topology because both have one hole. Topologists study how networks like subway systems stay connected, even if some stations are closed. Their work also improves internet routing, ensuring data reaches its destination efficiently, even during heavy traffic or outages. Combinatorics. Combinatorics is the math of counting and arranging. It explores how many ways things can be organized or combined. For example, it's used to calculate how many seating arrangements are possible for a group of friends at a dinner table. In computer science, combinatorics helps design algorithms that solve problems efficiently. It's also crucial in genetics, where scientists study how different combinations of genes create unique traits in living organisms. Only 2% of viewers are able to click the video on screen before I finish counting to 3. Ready? 1, 2, 3. Click now to watch the next video.